Greetings, my name is Ross McLean.
And I'm Kasha Kwasniak, and today we're going to show you how to conduct the decomposition of a hydrate in LateNiteLabs.
In this experiment, we're going to be using 5 grams of copper 2 carbonate hydroxide hydrate, a scale, a crucible, and a Bunsen burner. First, we're going to get the scale from the Instruments tab and place it on the counter. The scale will be used to record the mass of chosen objects. Next, we're going to get a crucible from the Containers tab and weigh it using the scale. The crucible will be used to hold all materials during the experiment. Record the mass given, and then drag the crucible onto the counter beside the scale.
Next, go to the Materials tab and click and drag the copper 2 carbonate hydroxide hydrate to the crucible. When prompted, add 5 grams of the hydrate to the crucible, and then put the crucible back onto the scale. Record the crucible's mass again, then go to the Instruments tab and take out the Bunsen burner. The Bunsen burner is used to apply heat to the crucible. Click and drag the crucible containing the hydrates to the Bunsen burner. A stand with a metal wire crucible tray should appear automatically. Then, click the dial on the Bunsen burner once to adjust the flame setting to low. Now, double-click the crucible and check the box labeled Show Contents. This will allow you to observe the reaction occurring. As the crucible is being heated, watch for a color change in escaping gas. Once this occurs and finishes, turn off the Bunsen burner and drag the crucible back onto the scale. Record its new mass, and then click and drag all instruments and materials to the waste recycle bin.
Here is the balanced chemical equation for the decomposition of our hydrate. Notice how the stoichiometric coefficients are included to balance the equation. This displays the conservation of mass because the amount of each atom initially has to be the same in the end. At the beginning of the experiment, the hydrate added to the crucible was green, but after heating, a new black solid was formed. This new solid is copper oxide, as noted in the equation. The other 2 compounds produced, however, were gases. They were released during the heating of the hydrate. Decomposition reactions consist of a compound that, when heated, lit, or electrified, breaks apart and forms new compounds. Apart from the color change and observed gas release, as described earlier, there was also a decrease of mass in the crucible.
Since we know the end mass of the copper oxide and the starting mass of the hydrate, the amount of gases released can be calculated. We can also calculate the amount of each product we should have after the reaction is completed through stoichiometry, which we can use to confirm the identities of the masses in the experiment. These are the calculations that show the theoretical masses of the products.
Here, we have the calculations of the product's masses using our data from the lab. Comparing it to the theoretical masses, the sum of all the masses add up to 5 grams, which is the same amount of mass that we started with. This agrees with the conservation of mass. You can see here that the theoretical masses calculated on the previous slide and the actual masses calculated in LateNiteLabs match up, thus showing that our calculations were successful.